Thank you. There we go. Yeah. I yes, I'll try to give an overview of everything we have done. It's a little bit about the hospital area itself, the main hospital area. You see, there's new buildings here in the hospital area. And also, I'll talk a little bit about those in general, and then specifically about the sterile central and the automation in the sterile central. Um, of course, I won't read the Latvian. It's not my strong suit. I will read from another screen here in the English version, and hopefully you will follow. Okay. The hospital project, one of the bases was that it was supposed to be, it is an integral part of Malmö, the hospital. It's always been near the center of Malmö, and we wanted to keep the geographic convenience for the citizens to have an advanced, highly technical, centralized hospital in Malmö. It's a public safety issue too. Everyone has easy access to the hospital. You can walk there, bike there, or easily go there by public means. And let's see. For the new hospital buildings, it's a big process, of course. It's a massive investment. It's over 12 billion Swedish krona, so around 1.2 billion euros invested in Malmö. It's a big project. It takes a long time to plan it. Here's the timeline for the project. From the original decision, 2013, planning, and of course, the revised decision when we knew how much it would cost, so a budget increase in 2017. In 2017 was also when I joined the project, so this year it's the 9th year I'm in the project, actually. So it's an exciting journey. We started construction in May 2018, and with the service building, and then the construction of the main hospital building actually started. No, that started in May, and the service building in August. The hospital building was, of course, a much bigger project, so it took a long time to complete it. The service building was done a lot before that and could service the entire hospital at an earlier stage. Let's see. If we look a little closer at the service building, it's located in the hospital area in the corner for easy access for trucks and transports. The main hospital buildings the new ones are in the center of the hospital area, and the entire hospital area spans a couple of city blocks here. It was completed, as you could see on the timeline, somewhere around June 2022. It has 27 square meters. In the building, we have the laboratory. It's open around the clock. We have pharmaceutical supplies coming in, hospitals, technology, some joint systems like medical gases, etc., originate from there. We receive goods delivered, meals, waste management is handled there, postal services, And there's also educational, administrative premises. All the technical stuff resides in there as well. So, who service the entire hospital area. The laboratory is basically fully automated with a Tempus 600 system, which supplies the laboratory with sample tubes. People at the wards just put the tube in the hole in the wall, and then it appears in the laboratory like half a minute later or something. We also have a pneumatic tube system, which is connected to the laboratory. And the laboratory automation works in a way that you only touch the tube once when you take the sample. After that, everything is automatic, and you get the result of all the samples in 30 to 45 minutes. So there's no emergency track for samples anymore. It's not necessary. Everything is fast. Technical infrastructure, that's everything that's not visible. I have been working with the AGV system, automated guided vehicles, so autonomous vehicles serving the hospitals with transports. Also the pneumatic tube postal system, which is largely in the basement of the buildings, and also connect to the various floors for small goods transport. Other parts of the infrastructure project is power systems, of course, telecoms, water, medical gases, and sprinklers. So it's been quite a big project, that as well. If we look at the main buildings we have built, there's 2 hospital buildings actually. This one, the main one, it's shaped from above like an H, where you have elevators in the middle, you have wards on the top floors, and where patients stay, and then at the very top you have administrative like offices. And then we have, of course, the surgery wards, the sterile central, and all the receptions for patients. The receptions are at the very bottom 2 floors for easy access for the patients. All right, everyone follows so far? Yeah, hopefully. About the size of the hospital buildings, it's approximately 108,000 square meters. And they're separate but connected. One of the buildings have 10 floors, the other has 11. And in those, we have 10 hospital wards, 240 single rooms for patients, and we have 23 operating theaters. We have outpatient and daycare units, and planned surgery, of course, also an intensive care unit, also with also specially designated beds for children.
Erik, may I have one small comment for
Yeah.
others? Tās nav domāts 10 slimnīcas palātas, tās ir 10 nodaļas specifiskas. Okay, Erik, thank you.
No problem. The main topic, of course, is the sterile central, which is located just next to the surgery wards inside the main hospital building. And we decided at an fairly early stage that given the location of the sterile central and that we cannot grow the space, it's fixed space inside the hospital building, and we don't have a lot of space. They wanted more space for surgery wards, etc. So to be able to deliver the quantities needed every day up to a maximum of 105 operations each day, or surgical procedures each day. We needed automation to save space and to increase productivity. Also, I will get to that. This is part of a few pictures of what we have installed. These are the washing machines, the disinfectors. And here is one of our robots in the unclean area. Well, I'll talk some more and then I'll show you some more as well. So I've been asked to talk a little bit about what to think about when planning automation. It is fairly new for the hospital sector with this kind of automation with robots and everything. So there's a lot to think about. We had some previous installations to look at, but for Sweden, this was completely new. So we've been looking in Denmark, we've been looking in Germany, how they've done it before. Of course, we've learned a few lessons on the way as well, and we'd like to share them with you. But the most important thing, of course, is to start with going through all your processes and flows. What are you actually doing each day? That has to be absolutely clear. How are you working today? We have to start there. How are you working today? How can we simplify or change the way we work today without thinking of automation? We eliminate all the waste in our processes and look at what's left. When we have done all this, and it takes time and it's probably a lot of discussions and maybe a bit painful, but at the end of this process, we need to really describe what's left, what we need to produce in the sterile central in detailed use cases. And those can then be used to change certain processes done by hand with automation. So don't start with the automation, start with looking at your processes and then try to figure out what's suitable for automation. So we need to identify all the activities that are suitable for automation. So we did for example, we looked at the process of the unclean area and handling trolleys filled with used instruments, used material is automated on automated tracks. Emptying the trolleys is also suitable for automation because it's heavy lifting. Some things are heavy, it's a repetitive work all the same. It's not highly complicated, it's just emptying a trolley. But the actual washing, the pre-washing and inspection of the instruments is too hard to automate. So there we have manual labor doing all that. So, and also we discussed autonomous robots driving around the materials inside the sterile central too. But the staff did not want to just stand in one place all day. They wanted also to be able to move. So they want to move empty trolleys. They want to move materials from the washing tables to the dishwashers, for example, so that they don't just stand around in a stationary all day. Also, they, of course, rotate different positions. Yes. I heard you have, as we did also, you have an existing footprint. You have like an existing building. You want to fit your automation inside. Of course, we need to consider various features. There's probably columns supporting the ceilings and roof. For example, we need to choose wisely what robots we have to fit existing rooms. You cannot have too large equipment. You have to have space for service and maintenance, etc. Maybe you have, probably you have a lot of ventilation holes with filters that need to be changed. You cannot put like conveyors next to that. There's a lot of things like that to consider, that we've had to consider. We've been building a new building, but it's been very difficult nonetheless to cover all those things. So you really need in the team, you need someone with very good knowledge about the building systems who can be in the team and make sure the automation doesn't block anything. Of course, for efficiency, straight conveyors is the best. Finding a layout that allows you to have the most efficient daily work process, of course. There's a million more things to consider, of course, but I'm trying to name some of the most important. If we go further with the building constraints, of course, there's a limit to how much weight you can put on the floor load. That has to be considered. The optimal layout may not allow for a robot in certain places. So it's going to be like back and forth. You have to optimize this probably by redoing the solution a couple of times. Something we've learned the hard way is that sound does not stay in one place, it travels. When our robot is working, everyone knows about it in the rooms nearby. We can hear it all over the administrative area. We can hear now the robot started packing. So everyone knows. And that's difficult to handle. Noise that goes down into the concrete and spreads, but it definitely needs to be addressed before you have the robot on site. So that's one thing to be considered. Of course, dynamic loads. It's one thing with a robot that weighs 500 kilos, but when it starts moving, the loads change and get dynamic, and then you may experience cracks, etc. So you really have to look at what the floor can take. Ceiling heights, important. When we started running the robot, we discovered that nobody thought about there's a filter just above the robot. And when we take the baskets from our warehouse, the robot puts the basket like 5 centimeters from the filter. So we had to move the ventilation actually to be able to comply with the hygiene demands. That's something we discovered at a late stage. Of course, it costs more to do that. We were lucky we could do it. Also in the ceiling, you have sprinklers, cable trays, vent duct. It's usually pretty messy. So, and everything affects, of course, the where you can place stuff. Escape routes, of course, fire compartments. That's also interesting. if a fire alarm goes off, should the entire automation stop, or just the robot cell, or what do we do? In our case, we are thinking if the fire alarm goes, everything stops and everyone exits, of course. But you may want to do it differently. It's also, as I mentioned, maintenance, accessibility. There's a lot of maintenance in a sterile central. You change filters. You have to maintain the automation, of course. There's other stuff that needs to be handled, and also cleaning, of course. Daily cleaning is highly important when it comes to designing the automation as well, so that you can access the floor if you want to, or you close off the floor, you seal off the floor. If you don't, if you cannot allow for proper cleaning under the automation, you need to seal off the floor instead, so that no dirt can accumulate. I have to think about these things, because some equipment maybe have 2 centimeters from the floor, like an open space. How do you clean that? It's very difficult. So clearance and things like that. Of course, development is going quickly. So on top of all of this, we need to think about flexibility and how do we, in the future, change certain parts of the automation. Maybe we want to automate something in the future that we cannot do today. So we have to think about how to do that, or how to create the possibility to do that in the future. Yes, some important points to repeat shortly. It all starts and stops with the processes. What do we want to be able to do? And how do we do it? That's the most important thing. The automation is secondary to that. You need to, before you buy anything, you really need to do a preliminary design. And for that, you will need expertise. We've used consultants within the automation field to be able to create like the first draft or the main layout of the automation. And that actually still stands now, when it's 90% the same as we did in the preliminary design. We also did a simulation to look at with this preliminary design, can we meet the capacity we need? Like, how many autoclaves do we need? How many washing machines? How many baskets do the robots have to handle, etc. The use cases is a tool often used in software development and IT, where you break down the process into activities, and you define those very precisely. What do I want to be able to do? What's supposed to happen when I do it? What systems are involved? Exactly which information is exchanged, etc. And my experience is these cannot be too detailed, because if you're not detailed enough, you will have things that are unclear when you have suppliers coming in, and costs will rise because you will not have it in the procurement material. So this is an opening. If we're not precise enough in what we want, there's an opening for suppliers to demand more money to do it. And we don't want those openings, do we? So, and the procurement process, we did a very, very extensive work, but there's always gaps. Everything needs to be clear and measurable. Use cases need to be described in detail. We need to define exactly what the supplier needs to test and how, based on the demands we have and the use cases. We want clear documentation, documented testing from the supplier before we can even talk about doing any approval testing, site acceptance testing, things like that. You need to be very strict with those things, because my experience is otherwise the suppliers, they kind of take the chance that things are working and that the site acceptance test will be approved, but it's not necessarily the case. And if a supplier, if you plan a site acceptance test and you then want to start using your equipment, if the supplier cannot meet your requirements and you only find out at the site acceptance test, you will probably have big problems with your time plan after that. And since we are serving the surgical wards, it's probably pretty devastating. Yeah. Am I on the right page here? Sorry. Yeah. And you need to have someone to follow closely the installation and testing so that the supplier is not doing it on their own. You need someone to follow them and make sure they do their job properly. Right. If we go to capacity, our sterile central is supposed to be able to supply materials to 105 operations per day or surgical procedures. And that, of course, in our case at least, it translates into around 360 to 430 baskets, containers each day. And they are loaded into 190 trolleys, case carts a day. And these are the overall capacity demands, but those can then be broken down to a capacity needed for each zone. You need to be able to process. If you have 4 autoclaves, each autoclave needs to be able to do a quarter of this, at least, maybe a third, so that you can have one autoclave out of order and still make the capacity. The automation is dimensioned to not be the bottleneck. With that, I mean the automation is never supposed to be the reason that things are not going through in the correct pace. We have chosen to put the bottleneck in the process equipment, or kind of depends. We're trying to work out the process equipment so that the bottleneck actually ends up in the manual work, because that's also scalable by using more staff, etc. And it's also good that the staff can set the pace and not the other way around, I think. We don't want people to wait for the automation. The automation have to wait for the people. Okay, let's see. What did we do? We did a simulation. This is like a small picture. We built, of course, the entire sterile central in the simulation software. Actually, consultants helped us do it. That way we could visualize how the space looked. We could look at the capacity in different areas and change variables to help us also set the right demands and the requirements in the procurements. We can get a sense of workplace safety. And of course, this visualizes to the staff, how is it going to look at the end? We did some other things to visualize, which I'm going to show you as well. This is seen from above, our main layout in the automation. We have surgical wards. If you look to the south of the picture, the surgical wards are below here. So used trolleys are coming in. Can you see my arrow? I hope so. Used trolleys are coming in here in the southern part, yeah, to the blue area. This first part is a conveyor belt, but it's also an elevator because used trolleys are coming from the surgery wards on the floor above us too. Then they are moved to a circular buffer here. Actually, there's two in the picture, but there's really only one in the reality. I don't know why. There's something wrong with this picture, but never mind. There's a circular buffer which can hold something like 250 baskets. To kind of, you catch the flow here, and then the staff at the washing tables can work in their own pace and order baskets to work with at each workstation. When that's done, they put them in the dishwashers here. The trolleys goes out this way and to these cabinet washers where they are washed. And then everything is moved over to the clean side. The trolleys are moved over here, over to the sterile side and onto the automation for packing again. And all the instruments go through here, goes to the packing tables. The packing takes longer than the washing, so you see we have more packing tables to account for the capacity. Then when everything's packed in containers, it's registered in T-Doc and moved along this conveyor over to another buffer where the robot is working and loading autoclave racks. The autoclave racks are then put on the conveyor in the what's it called? The sterilizers, autoclaves. And after the sterilization process, it's in the sterile zone, which is this zone here. And another robot is unloading the baskets, moving them to the automated sterile warehouse. And from there, it's automatically loaded onto trolleys. You get orders for, you input in your planning tool what surgeries you're doing tomorrow, and then this automation packs all the trolleys. Trolleys are subsequently moved to our vertical storage and put in there. I'm going to show you a brief picture of that as well. And yeah, it can hold 54 trolleys. So you have room for plenty of surgeries. So you can actually prepare for the surgeries done tomorrow, the day before, and of course not all of the surgeries, but at least the ones in the morning. All right. Let's see. We also did at an early stage to further get good visualization. Our architects built a model of the sterile central, just to see also how do we fit all the equipment, because there's a lot of equipment which goes inside the sterile central, of course. So that's symbolized here by various symbols and people. And we also had robots built by Lego, which was quite interesting, to like give a sense of how things would work out. We analyzed how the sound would travel. Our main packing robot is over here. You see that's a red spot. What we didn't take into account is the administrative area, and the lunchroom is here. So when that robot is operating, you can hear it all through this section. So that's something to consider. Otherwise, we have tried to seal off the noise so that it doesn't travel to the areas where people work. 50 decibels, 52 decibels, those numbers are practically dead silent. So it's a good environment to work at the main manual workstations, at the washing and at the packing. I have some more pictures here. This is by the automated receiving and the buffer on the unclean side. The trolleys are fed by automated conveyors here. They are moved by a transfer trolley here between various conveyors. It's put in front of the robot for the robot to empty all the baskets, put on another conveyor, which is fed to this robot over here, which is inside the round buffer storage. And here we temporarily store all the used baskets and containers before sending them to the washing tables at the pace decided by the staff themselves. See. Yes, this is kind of a text describing what I just said. The inbound conveyors are totally separated from each other, so there's redundancy. Also, the control cabinets are separate, so if one goes down, the other one keeps running. Everything is scanned, of course, for traceability. It's logged in Getinge system, TDoc, where everything is. So when the trolley arrives, it's noted that it has arrived at the unclean side, and then we also get a notification when it's emptied, and then we can follow up that it has been washed, and in the end that it's been packed again and delivered. So traceability all the way around. The baskets are also scanned and traced. We know what baskets are where and in what trolley and etc. And eventually which operation or surgery they're going to. So it's all interconnected. And that's a major project on its own. The IT side is not to be underestimated. It's a massive project. We have a project manager working with the IT project. He has two deputy project managers and a security expert. So there's a team of at least 4 people working just to manage the IT project. And of course, the suppliers are part of the IT project. Getinge is part of it with the TDoc team. The Orbit surgery planning team, surgery planning software team also. And the other suppliers, of course, the automation supplier, the supplier of the washing machines are also in the IT project. And that's a massive challenge. We also have the automated warehouse, sterile storage. We have the capacity for 3,200 baskets. We have 3 automated cranes. You can see there's a crane at the end of this aisle, but it's not very visible. But the automated cranes extract the baskets and sends them to a conveyor belt, which takes it to the packing robot, which then packs the trolleys. We can pack 32 case carts per hour, trolleys. And that translates to nearly 100 baskets or containers per hour. Depends on the filling rate, of course. If we put more baskets, containers in each trolley, it takes a bit longer. Sterile side, all baskets are stored in the sterile storage. Packing is, as I said, it's triggered by an order for a specific type of surgery or a specific surgery even. Packing is initiated good time before the start of the procedure. The instruments are mainly handled in containers nowadays, or will be in the new automation. There's also, of course, a limit to the flexibility, so we have chosen to go with 3 heights of baskets that are handled in the automation. The 45mm baskets are only used for containers, nothing else. So the container is placed on these 45mm baskets and handled in the automation. The 100 and 200mm baskets contain supplies, sterile supplies to the surgery wards. Sorry, I wasn't showing the correct picture, I just realized. As I mentioned, we have a vertical storage as well. It's an elevator system. 56 case carts even we have the capacity of. There's 2 fully redundant systems, so we have 28 in each. And as inside it's ISO class 8. All openings are in the green zone, so everything is sterile inside. We have a very advanced ventilation system and a height of 30 meters. And this is a complex unit. It's not to be underestimated. I had the hospital in the Faroe Islands. They installed one of these units, but had to tear it down and redo everything because they didn't have enough ventilation. So it can be costly not to plan properly. Right, and this is actually my final picture, I think. Yeah, this is the automated packing of trolleys and the automated packing of autoclave racks. Here is the packing of autoclave racks. We have a buffer of empty autoclave racks, which are moved by this transfer trolley to the robot. The robot packs from a 6-story buffer which is filled with containers and baskets. And this transfer cart also distributes the autoclave racks between 4 sterilizers. And we choose always the sterilizers which has the least amount of processes run. So we try to distribute evenly so that the autoclaves are run as equally. So we don't run autoclave number 1 all the time, but we try to equalize. And this robot over here is the packing robot for the case carts. So we can pack 2 case carts at a time, and all the baskets come from this conveyor. You can see just the end of it, just near the ceiling. And you can also see the ventilation here that we had to move because it was too close to the robot. So it's now situated over here somewhere. Right. Now I think we have time for some questions, Gundas.
So, okay,
Maybe.
thank you, Erik.
Thank you.
Yeah, it was really interesting. Yeah, we have several questions.
Oh, that's good.
Yeah, okay. Be prepared.
Maybe I can answer some of them. I hope so.
Okay, I hope so. The first one question is about humans.
Humans, yeah.
Yeah. What do you think about robots and humans? Are you planning that robots will make decisions instead of humans, or?
No, we're not planning on any robotic decision making, actually. Not apart from optimizing what autoclave we should use or sterilizer or things like that. But no, but not on the management level. No, there's always people deciding. What the surgical program, for example, is set by humans, of course, and but that the orders are automated. So based on what's needed for the surgery, the system orders it automatically. So that's not a person ordering all the instruments. So some of that's maybe not decision making. There's a human who has decided what instruments are to be used in the surgery, but then we have automated the process of actually ordering it.
Okay, so robots are for heavy works, yeah? For heavy loads and so on.
Mainly. Heavy lifting. Things that would destroy people's shoulders and,
Yes, to make our life easier, yeah?
Yes, to make our life easier. That's the main point, yeah.
So, and next one about those baskets. You showed that you'll have 105 surgeries per day.
Yes.
And it means approximately 300 to 400 baskets or containers per day. But you have sterile stock for 3,200. So it means that you are working not for tomorrow, but I will say it's 7 or 8 days in the future. Yeah, you have
it's possible. Yes, it's possible at least. We don't do all the surgical procedures every day, so we need to have like more containers, a variety of containers and baskets in the storage, so that we are ready to do all the surgeries we need to be able to do. So it's based on that, the variation we have, and also, of course, to have enough.
Okay, it means you have enough spare. Yeah.
Yeah. We hope so.
I hope so. Yeah, I will visit your hospital. I hope it's here, but I will contact with.
You're all welcome, of course.
Okay, and the last one, in the last slide, you showed ventilation. Yeah.
Yes.
So it means that every time when, at least, for example, you see Inese, she's planning
Yeah.
For these robotic systems. It means that you always need some specialist, some advanced specialist who is able to see what is happening around, yeah, and what you have
Yeah.
or where to have to put your robot.
Yes. Yes, we need someone who knows the building systems, and who knows. Maybe it's not apparent for everyone that maybe there's a filter in here that needs to be changed regularly. And what does that mean for the robot? You have to be able to stop it for a while you do the work. So you cannot have you cannot plan your capacity that you need to run the robot all the time, because then you cannot do any maintenance, things like that.
Yeah, okay.
Also for the access, safety,
Yep.
Yeah.
From my side, it's really nice. Thank you.
Thank
It was
you.
our first experience with lectures, not from Latvia, but from other countries. Really, thank you. About
Thank you.
maybe Ines also say something. We cannot hear you.
Oh.
No.
Oh,
No. Ines
what?
nav skaņas.
Don't you have a microphone? Maybe.
Yeah, she have to do
Yeah.
something with this because
No problem. I don't have a hurry.
she was asking me to organize this lecture about robotics in CSSDs because it's really, really important for us and
Yeah.
mostly our youngsters. And I will say she's really young.
Yeah.
Youngsters are planning during the next 5 years uh,
Okay.
to introduce
Mm.
robotics in CSSDs. Sorry, one moment. She's calling me.
Yes, she's calling you too.
Yeah. Savu? Jā. Ok, tā izslēdzu. Okay. Yeah. Additional question about expenses. What do you think about expenses, or how's your experience with expenses if you are using robots instead of humans?
Well, for us, it's not all about expenses. It's about quality. It's about workplace safety. It's hard, I should say, to motivate an investment in automation based only on cost and economy. I don't think that's the selling point. I think the selling point is more in terms of focusing the manual work where you actually do the most good. You remove the kind of tasks that are repetitive and heavy and may cause people to go on medical leave, That's important too, and it's really hard to quantify in terms of money, how much money you save
Okay.
when you improve the workplace for the humans.
Yeah. Thank you.
So that's kind of where we are. Yeah.
It's really nice what you said now. because expenses, it's not a primary. Expenses is secondary. In our job, the main thing is humans' health, our health. Yeah, because we're also working with heavy loads, always. Our eyes, our brain, our hands. Yeah.
Number one is the patient. Number two is the staff. So
yes, I mean staff. Yes, at this moment.
Yeah, I agree. I agree. Yeah. So we need to provide something that is safe for the patient.
Yes.
But also is safe to work with and provides a good environment to work, and that people want to work there and think they have a meaningful job.
Yes, and make our life easier or our job easier. Yeah.
Yes. So it's not primarily about. I believe you can save money as well using automation in the correct way.
Yeah, but it's secondary.
It's secondary, yes, but I believe it can be done. But at the moment, it is quite labor intensive to build it and to get everything working. With IT, all the processes, all the software, everything working as it should, and making sure it does what it's supposed to.
Yeah.
Yeah.
Okay.
As always, yeah.
Thank you, Erik. It was really fantastic. It's our first experience with the foreign lecturers. It's really nice.
Thank you.
Thank you.
Yes. Thank you very much. Thank you.
Yep.
Bye-bye.
Yeah, bye.
Thank you.
Bye.